So in chapter 1, we talk about pretty much this concept of software engineering, right? So in this course, this structure pretty much just relevant to that because we have to make sure that it's cost effective, right? So in software engineering, is to look at the cost, documentation too. You have to have document. That's why we have Java UML diagram, right, for your code to make it easier for somebody else to piggyback you after you left, right? So organize the team environments, use other tools like we use JUnits, right? To test, this is the tools, right? To test your code. So, and we have the software life cycle, right? So life cycle means we start to first we test. So first, actually, we look at the problem first, right? Problem analysis, right? Like, okay, what's the problem? Now we start to create the application to solve the problem, right? Real world problem or any problem that we try to do. We start to create requirements for that, which we call specification. So after that, before we really implement, we have to design first, right? To design, it could be high level to low level, like from the top down, look at the whole picture of the application. So we can make an interface, right, for each operations, and then we can get into implementation in each method, right? So that top down. Or sometimes we do like bottom up, like low to the top. Like we actually implement each module first, each method, and then combine them up to be a class and then to be a package and then project, right? So that's just low to high. And after we design, then we start to implement. Then we have to deal with testing. We have unit test that we see that we test your program, right, after you implement it. And if it doesn't work, we go back and fix it and keep testing. So this is testing at your level. When you're done, you pretty much just make it. We have environments we call development environment because that's going to be on your machine. That when you develop. And when you're done, you have to move it to staging. So staging is where the program pretty much ready for the system analyst to test or software tester. They're going to have many ways to test. They have program to test your program too. Okay, so they have to do a lot of tests besides testing your logic all good. They have to test on load test, which is going to make sure that if there are a lot of people, like for example, Google has to have load test to test that if there's a lot of hits, million hits at the same time. So if there are a lot of things overloading your application is going to still behave as expected. Okay, and then also they have to have integration test. If your application integrates with other applications, it still work as expected. And they also have environment test. If you put into different OS, right, they still work as expected. Different hardware still work as expected, which is more work than developing. Testing is a lot more. And normally, if you say you spend time to develop like 1 month, testing is going to be like maybe 5 times. It's going to take longer because there's so many scenarios that you have to test, and you have to. We have like white hat, and white hat means the one who know the program, test the program. Like you are the one who develop it, you know everything about the program, you test it. And then we have black hat, like the one who didn't develop your program, doesn't know about it, like try to attack your program and make sure it's break. They can break your program. So that's the same thing like we try to do in the testing. So like all the statement, each line of code has to be test. Sometimes when you write program, you have many if else, but you never test the else case. You only test the if case, and you thought it's passed, but actually when it hit else, it can be abnormal, right? So that's why we have to test all the cases. All branching statement has to be, all line of code has to be tested. And after we pass the test, then we can verify, and then we can deliver that into the production environment. So production pretty much is live. User can use them. And then we come to how to set up the team for help desk. So when there's a problem, then we have the service we can help desk. Right? For example, like if you try to log on to your online banking, that's the live production application. And if you have a problem with logging in, then you call help desk, and then they're going to pretty much just, if there's a problem, sometimes they send an errors report, right? And that error report just go back as a maintenance, go back to the testing team, and testing report back to developers. Developer has to go and see what the errors and try to fix it. And that's the life cycle, and go back, and after you fix, sometimes when you make one line of code change, it can actually affect another errors. So the whole thing can be redone again. You have to do the whole test again. That's why testing has to have the program to do. You cannot manually test, like even the GUI application, like even like you click, move, you can actually, they have the program record that movement. Like we have like the name JRunner. Yeah, that's a program that can do the test. But we have like Selenium. This is for a web application. Like in Java, we can use that. Like we can automate the test, pretty much just like robot. Try to log in, try to put in username, password, and you just write Selenium to write that action. It's going to read your page, grab the form, grab the text. Because your page has a code, it's going to read that code, and then try to pretty much running it could be password from the dictionary by just keep putting in, and it can break into a system by randomly just generate all the password and username, and it can just log in authenticated. Yeah, pretty much that's automation for testing, like a Selenium. And this one for web, we have done it for the Java client application, like Java tester. So that's for the GUI testing marathon for Java. That's testing tools. Yeah, that's the price for commercial version per user. Is to test swing. And software engineer, we have what we call waterfall life cycle. So it's going to be look like waterfall. It's very common when you go to job interview, they're going to talk about what type of like software life cycle or development that you are in, environments of development that you are in. So normally a lot of government job of government, so they used to do like mixing between waterfalls, and they have Agile, they have Scrum, Sprint. So those are something that we have to look at. But waterfall is like this. Let's look at the waterfall first. So we look at the problem, right? The application going to say we want to do login authentication. What are the requirements? You see, just login, there's so many things that we have to involve. We've been doing that. So it could be you have to validate your text input, right? You have to protect the robot attack, right? You have to have captcha, things like that. You start to make the design, start to implement, testing, deliver, maintain. There's a problem, implement. If you have to change the spec on the application, You have to go back from the beginning, analyze requirement of the new spec, redesign, re-implement. This very costly as being like that. Now, waterfalls, you see, it's going to take time, right? Every time when you make small change, has to go to the beginning or something and redo it, the whole thing again. I mean, I see that being used in organization. Good thing about it is pretty much like clear step by step. Okay. But to develop application, it's too long. Which in this era, it's gonna be too late to deliver your application because it changed very rapid, right? So in order to fix that problem, that's why they have what they call Scrum, Sprint, and Agile. Okay. So now let's talk about Agile a little bit here. So customer involvement across life cycle. This is very important because most of the time when you write program, you're gonna say, is this what he's looking for? Is this requirement is not clear? I'm not sure. So that's why customer is going to involve, right? Instead of let's developer guessing and try to thought this is what he's looking for, I'm done, and we deliver, and then he said no, I'm not looking for that. Then you have to redo it again, which is not bad on both sides. It's not good for both sides, right? So you don't want to redo again, spend too much time, and customer just has delay of that product, right? So customer is just involved on this step now. So incremental development and delivery. Embrace change. Customer satisfaction is the primary goal. Okay, not the developer goal. Like, hey, you should do this because actually that's what I know how to do, or it's easier for me. Actually, you have to make whatever customer asks you to do instead. Pair programming. I think I like this technique. Sometimes when you write programming by yourself, yeah, maybe you're tired and you don't have second guess is always better than one. So more than one is better. Then you have your buddy just sitting behind you and look at your code and say, hey, why don't you do this and do that? It's just more fun. Okay, and so I've been doing that, like more fun, and it's more productive that way. Yeah, if you get a good buddy, right? Some goals of quality software. So we talk about quality software now. It must be, it works, right? If it's not working, then you just fail for the class. But for the career, you just lost your job, right? So it can be modified without excessive time and effort. So that's why I try to create a module, separate them, right? And you see that you have to make methods, and you can easily to decouple it, right? And modify it and maintain and upgrade. Don't have to do much time, and then you can do unit tests on that and put it back. You see we have utilities that we can just switching, right? Make it modules. And we have like model view controllers, separate them, right? So you have to don't have to worry about view and model, just worry about the data. You don't have to worry about logic, right? So this is very important. And reusable, like we see that your logic can reuse with different views, while we have to implement things again, right? So this is not like CSC200 class that you write program that everything in one page, right? And it's complete on time. When is the due date? That's a due date. Cannot be extended, because when you extend it, we have to pay you more. That's over budget. Alright, and we cannot deliver to customer on time. We lost